Hi, so the first notebook is going to be about data. And what I mean by data here, we're not going to get into the details of how to perform a data science task. Instead, we're going to be focusing on how to load your data into Julia and how, or what are the common data structures that you would use to store your data and what works best given the data that you have. In this notebook, obviously, data could be stored in a wide variety of different types of formats, but I'll try and cover the most common formats that I've encountered in recent years, and formats that come from other different programming languages as well. So we're going to do a part that's more like text files and CSV files and so on, and we're going to do a part that is more focused on what if I have a data from another programming language, how do I import it to Julia? And then we'll cover a couple of the data structures that are common for storing your data. So we'll go ahead and get started. Okay, so here, first of all, as I mentioned, or as you will see in all of the notebooks, I usually try and get my, this is not the right cell. I usually try and get all of my packages kind of loaded into the notebook so that I can get them out of the way. And usually if I'm using a function that is specific to a specific package, I try and say, well, we're going to use this package to process this like certain task. So I'm gonna keep an eye on trying to be clear on where these functions are coming from and which package is serving which purpose. So here I just already loaded a few packages. So we'll go ahead and get started with the very first function that I want to introduce you to. First, actually, before I keep going, I just wanted to say, if this is your first time dealing with a Jupyter notebook, or this is your first time doing Julia on a Jupyter notebook, the way to run each cell is by hitting the Shift-Enter key combination. All right, so Shift-Enter here, it's going to run it for a second time, and it's going to load these packages again. All right, so the first function, as I said, is going to be the download function. And again, if you're using Julia for the first time, you might want to know that the question mark keyword or key is going to give you the documentation of whichever function you're requesting. So question mark download is going to give us the documentation of what download is all about. So download is this Julia function where you pass the URL of the file you're trying to download as string, basically here. And then you could also decide on a new name for the file you're trying to download. Now, a quick note about this is that download actually relies on certain tools you will probably already have on your laptop, such as curl or wget or fetch. So just note that piece of information. Okay, so again, download is pretty simple syntax. So we're going to go ahead and get started with downloading a quick CSV file. So here I'm downloading a list of a CSV file, which is actually, let's go ahead and look at this URL. What is this URL going to look like? So it's already pasted here. Perfect. So it's really just year, language, and it's basically each row has a year, the language, and that is the year the language was created and what the language name is. So it's pretty simple. So we've downloaded it here, and it's currently in our local directory. And just a quick note again, you could do the same exact thing as download by using the wget or whichever, if you have curl or fetch. So using a semicolon here is as if you've switched back to a terminal. Semicolon wget is going to serve the same purpose as using download from within Julia. Using semicolon here, it's as if you left Julia and you went back to your terminal. Actually, as another quick example, we could use semicolon head on the same file we've just downloaded, and head is going to show you the first 10 lines of that file. And if you actually want to see, it's going to be the first, same as the top few lines here. All right, so yeah, again, semicolon is going back to terminal. So this is just kind of a sneak peek if you wanted to take a quick look on what this file looked like. So now we'll move on to the first two ways to actually read a text file. So CSV is still a text file, like it's inherently just written as text, right? So how do we read such file? There are two main ways to do it. The first way is using the delimited files package, which is in standard library. So if we do readdlm of this file here, we just pass the actual file name and we pass the delimiter that's being used, which is a comma in this case. And then we set the header to be true just because we know there was a header. And so if we execute this, we're going to see that P and H are going to be stored here. So if you execute H, it's going to be the header. And if you execute P, it's going to be the actual data. Now, quick note here, we're not going to get into the data structure used yet because we're going to cover that at the end of the notebook, but just note this for now. Note that we're actually, the type of this data is now an array of dimension 2. What that means, that's a matrix basically. You have, you could have an array of dimension 1, you could have an array of dimension 3, and so on, and this is of dimension 2. It's because it's rows and columns. All right, so that's the first way to do it. Let's go back to H. And then very quickly, how do we do the same thing but write the data? We could use the readdlm function, pass a new file name that we wish to name the new file, and the data that we wish to write, and the new delimiter that we wish to use. And executing this will be straightforward. Now, a quick note about delimited files. I would only recommend using delimited files if you actually have a really complicated text file. If you have a text file just like this one, which is pretty simple and straightforward, and it's a CSV file, I would strongly recommend using the CSV package for several reasons. One of the main reasons is, first of all, it immediately loads it as a data frame, and we'll see that that is the second type that we'll cover. And the second part, which we'll see later, is that CSV is going to be much faster on CSV files. Delimited files actually gives you a lot of tools you can play around with. So if you have a more complicated file, text file, you can use readdlm in that case. All right, so using the CSV package, we're going to read this data. And very quickly, we're going to see that, okay, this is taking a little longer than I expected, but maybe, yeah, okay, cool. If we do the type of C here, it's actually a data frame. So note that this is the second type we're covering here. And then if I just want to take a sneak peek into what C looked like, again, I can just do rows 1 through 10, and this column just means that we don't care which columns we're showing. So this is very similar syntax to MATLAB if you've used MATLAB. So these are the first 1 through 10. What's cool about data frames, and that's why I said like it could be interesting to load things as a data frame, is because you can actually load things by a column ID or symbol, if you want to call it. So if I do C of year here, every column does have a name. So it could, there's year, and then there's, so again, if I do C here, you're going to see there's year, and then there's language. But if I go back to C exclamation mark, comma, year, or we can actually do it in a different way. Let's do C of year, and then comment this out. It's going to give you the column right away. What's cool about this is that if you have so many columns, you don't want to remember, oh, which column was year, how can I find it? You can just use C.year and it'll just get it right away. Okay, so that's about it for reading from a CSV file. So I did mention that CSV is going to be faster. So let me run this cell here. And you'll see, so beat time is this macro function from benchmark tools, I think. Benchmark tools, yes. And it's just gonna benchmark these two lines of code, and it's gonna take a little bit of time just because it's gonna run multiple runs. But while this is running, let me tell you, yeah, we've seen the type of P originally from reading using readdlm. It's here the type is data frame, here the type is array of dimension 2, and then the top 10 lines are going to look very similar to the top 10 lines here. All right, and then quick things about data frames. So names of C is going to give you the column names of C, so you can very easily get access to what are these columns representing. You could also use this describe function. So if you're an R user, you probably know most of the things we're covering about data frames here. But these are very powerful tools for when you want to just take a quick idea on what your data looks like. So here, describe C is going to give you some information about like when was, if you like median, min, max, here's the min, median, max of the years, and so on. Now, this is a very simple data set. We will see later that we're going to use some more complicated data sets. And the more complicated the data set, the more beneficial such type of functionality is going to become. All right, so we already ran this as a proof that CSV is going to be faster running on the same exact file, reading it. So here we're going to see that CSV actually took about, almost half the time and about half the time in terms of allocation. So I would say that's pretty interesting. So if you really have a simple CSV file, not a simple CSV, it's just a CSV file. Just use the CSV package. Only use delimited files if you have a more complex text file. Right, so wrapping up this part, also you can do CSV.write. So that's also the equivalent of, like we already saw, reading and writing using delimited files with readdlm and writeDLM. Now we're just going to do the CSV.write. So that's going to be straightforward. Quick note here. So here I'm passing data frame of P, and the reason I'm passing data frame of P is just to show you if you didn't already have a data frame, it's pretty easy to convert it into a data frame. So if P was this, again, P was the matrix, not the data frame. If P was the matrix and you want to write it using CSV, you can just call the data frame constructor on it. If you already had a data frame such as C here, you can just pass C, so that's no problem. Okay, so this already wrote the file, so that's fine. So that's about it for just plain text files. The next thing we're going to move to is Excel files. So a lot of times you can have data sets with like an Excel file with multiple sheets and a lot of missing values maybe, and like missing cells and so on. So XLSX actually is this package that will help you read that such type of data. The format is pretty straightforward. You would pass the file name, the sheet that you're interested in, and the cell range. Now, you could say, what if I don't know the cell range? If you don't know the cell range, that's fine. You could actually run the same exact data here. I'm using the same exact file with the same exact sheet name, and you don't need to pass the cell range. Actually, yeah, it's a different function, read data and read table. But what I would say here is if you actually know the cell ranges, like if you actually take a look at your file and you know these are the cell ranges, I would strongly recommend passing the cell ranges just because, so in Excel, if you reach a point where like there's an empty cell, whether it's like an empty entire column of empty cells, that doesn't mean that the file actually ended. So XLSX.readTable is going to do the extra effort of looking beyond that. So it could be sometimes, if you have a complicated file, it could be sometimes more complex to try and read everything correctly. So I do recommend passing the cell ranges if you have them. I actually will pass on running, or let me actually run this. You will see that this is going to take longer, and for two reasons. We're not passing the cell ranges, and the data, as you will see when it's loaded, it's actually so big. So while this is loading, I'm just going to go ahead and explain what this data is all about. This is data I downloaded from Zillow, which is an app, or I guess an app, to if you wanted to rent a house or buy a house or so on. And it has data about since 2008 about sales, and it actually has all sorts of different kinds of data, but I downloaded this data set where basically it's the first column is a region ID of a certain region. The second column is a region name, and there's multiple columns of what the region identification is and its rank. I think there's something called rank. And then from it shows information from 2008, March 2008, up until April 2020, because I just got it in April. And in this specific sheet, which is sale counts, it says this number is the number of units sold in that specific region ID, which we also have their corresponding state name. So yeah, it's the number of sold houses in that specific month of that specific region ID. All right, so this is still working on it. So let's actually keep going to see what things are gonna look like later. One interesting thing, as you've noticed already, that this loaded things as a matrix. You will see when this actually finishes loading, what it will load is two things. First of all, it's going to load the data, like G of 1 is going to be the data, and G of 2 is going to be the header or the column names of everything. So in this case here, when we actually run G of 2, which is the header data of 1 through 10, it's going to give us the first 10 column names. So the first one's going to be region ID, second is going to be region name. There's a few missing here, right, because the display doesn't show all of them. So it's going to show us the first 10 column names. When we run G of 1, what you will see is that it's not going to be super pleasantly looking matrix. What it's going to be a collection of columns. And the reason XLSX does it this way is because sometimes in an Excel file, you don't have necessarily the same column sizes across every column. Like Excel files could be somewhat tricky in that sense. So this finished working. So let me actually show you what G of 1 is going to look like. So it's going to show us 148 element array. So this is an array of dimension 1. But each element in that array is actually a vector. So if I call G of 1 the first element in that data, it's going to be a vector of everything that happened in that specific vector. So let me actually go back to here and then show you if I took, this is the data itself, and then I took the first column out of this data. And then I want to just take a look on the top or the first 10 elements in that data. It's going to be the years here. And if you actually look here, it's going to be very similar to, well, it's going to be exactly the same, except one is missing to this data. And so that's the actual data itself. And again, the reason it gives us like a set of vectors rather than all vectors together is because Excel files could be tricky in that, in some sense. So G of 2 here, as I mentioned earlier, is going to be the actual names of the columns. So if I call G of 2 and then ask for the first 10 column names, these are going to be the first 10 column names. As you see here, region ID, region name, state name, size rank, this is the rank of that region. And then we're going to see columns of dates from 2008 up until 2020. Okay, so that's about it. It's pretty easy to convert it to a data frame. All you have to pass is G of 1 and G of 2. So let me take a second to explain what's going on here. So when you want to pass a data frame, let me see if I've actually done that here. I haven't. So you could do two things. One thing is you could just pass a matrix to a data frame, and what that will do is that it will just pick arbitrary column names. So if I actually show you let me see here, frame of P looked like. See, it just selected X1 and X2. It didn't actually decide on the titles of these or column names of these columns. But here I can pass data frames of, or data frame of G of 1, which is actually the data. It's giving it like column by column, and it's deciding on the column names themselves. So if I run this, you will see it right away gave me the actual data, and then it decided on the column names from G of 2. I'm going to cut this again and go back to this format, which is the splat format. I really like this just because what it does is essentially, so G of 1, G of 2 is actually a tuple. So let's see what G actually looks like here. So it's actually, let's do type of. Yeah, so it's a tuple. So it's a tuple of the first element is an array of all the arrays, right? And then the second element is also, again, an array, but this time it's a symbol. What the splat operator does, the 3 dots, is that it basically unwraps this. So G of splat is actually equivalent, or G splat is equivalent to unwrapping this tuple and making it G of 1, G of 2. So I'm just gonna run this again. That's gonna be pretty straightforward. Okay, so now we have a data frame. It's pretty easy to convert that data we read from Excel to a data frame. As I mentioned earlier, there's several reasons why you might want to use a data frame. That's another one of them. So I can just get a quick summary of the sizes of this data frame D. Obviously, I couldn't have done that with like G, which was an array of vectors, or P, or anything like that. So I could just do by on the data frame D by state ID, and then just give me the size per state ID. Another quick reason why data frames could be cool is the join operator. So let's just actually create our own data frame here. So if we actually create, we have a certain set of foods, and then their calories, and then their prices. And let's just create a data frame of the foods themselves and a data frame of the prices. So what's going to happen here, let me actually cut this and paste it in a different cell. So if you see here, data frames of prices is only going to have the food items and the prices. So items equal to food and prices equal to prices. What's cool with data frames is you could join them immediately on a certain item. So if I have the data frame calories and data frame prices, I can just join them on the item keyword. And you will see that here it's just going to give us the collection that combine both of them together. So that's another reason to do it. Yeah, so that's another way to build a data frame. Yeah, that was, I already explained that, why you would want to use a data frame with the actual names of the columns, because here you are using just arbitrary column names without giving them their actual names. All right, so wrapping up the XLSX part, you could also write an XLSX file by using xlsx.writeTable. One interesting thing to note here is if you already have the file name in your directory, this is not going to work, because I think I already have that file name in my directory. It's not going to like it. Yeah. So it says already exists. So you have to pass a new file name or delete, do some sort of your decision. You could delete also the previous file. So I'm actually not going to run this just because it's going to take a little bit of time to actually write the table, but I think it's usually like a minute, no more than a minute. Just keep in mind that this is actually a really large data set. So if I go here, it's about, it's 28,000 rows in 148 columns. So it is a somewhat big data set, and writing it to XLSX could be a little more tricky than writing it to just a text file. But feel free to run it yourself. All right, so now we've covered text files, and the form's just text files like CSV files, and we've covered XLSX files. Now we're going to move on to just the idea of importing your data from, say, another programming language, or someone gives you some data. Even in Julia, there's the JLD format. So if someone gives you data that is already in a different format, how can you load it to Julia? And we'll just go over them really quickly. They're pretty straightforward, to be honest. If you have a JLD file, which is Julia's file format, you could just use the JLD package using JLD and then jld.load. So one thing here, the reason I would call jld.load and not load itself is because in this specific notebook, I'm using a lot of functions or a lot of packages that load data. For instance, there's the same function here in our data. So just to make sure that I'm using the correct function that I want, I am specifying which which package is that function coming from. So reading and writing pretty easy. Loading data as jld.load, you just pass the file name, and now that you have a file format here, jld.data as _data, you can pass it back here, decide on the file format, and also decide on what it's going to be called inside Julia. So like if I want to re-import this file, the actual name, the variable name is going to be a. Same thing with NPZ, or similar thing with NPZ, which is if you're using NumPy on Python, that's a very common file format to use, NPZ read and NPZ write. Our data, very similar, it's an R data frame or RDA. You can also, we'll see how you can convert it to a data frame pretty easily. You'll use the rdata.load function. Now, quick thing about R, there isn't currently something as straightforward as let me just save it via an RDA and so on. And that's because like if you actually read, there's an issue about it on GitHub here. The current recommendation is to use the rcall package, which is just an interface between R and Julia. That allows you to run and execute R functions from within Julia. So here, when I'm calling using rcall, we're going to be able to write R code in just a second. The rput macro is coming from the rcall package, and what it's putting is that it's putting this data, R_data, in the scope of an R. In the scope of R when we're going to run it in just a second. And here's where we're running it. So when we type R, quotation marks, and then write, this is basically we're writing R code here from within Julia. So this is going to work just fine. And actually, just a quick note here, at the end of this tutorial, not this notebook specifically, just like the entire course, I think it's before the last notebook, we're going to cover how you could interface with other programming languages. That's not specifically a data science task, but I do know that if you're starting as a data scientist in Julia and you've already worked as a data scientist on another programming language, a big challenge could be how can I use my previous codes written, say, in Python or R? How can I use them from within Julia? And that's actually pretty easy in Julia, but we'll get to that later. Anyway, so we saw here that also worked. Finally, with the mat, so if you use MATLAB, one way to read and write your data is pretty straightforward, mat read and mat write. So here, before we wrap up this part, I actually just wanted to show you what the data is going to look like. And so the data here, if you see, this is an array of dimension 2. We've already seen a type like that in the P matrix that we saw earlier. Now the other stuff are dictionaries. And so let's see what does a dictionary look like. So a dictionary is really, well, if you've taken any data structures course, you know what a dictionary is. It's basically you have multiple elements in we call them as keys. So these are the keys that for a given key, there's a certain value. So if I call here JLD of temp data, I'm going to see that I'm actually going to get the matrix here, which was the actual matrix stored here in this very small mytempdata.jlt. So that's how things are going to look like. If I'm actually going to look at NPZ, it's just going to have the data itself. Very similar with MATLAB data. Again, it's going to have a dictionary of the value, the key, and then the values. So far, I just want you to note that we've actually seen 3 types of data structures you could use to store your data. We've seen the matrix type, which is an array of dimension 2. We've seen a data frame, and now we're just seeing a dictionary. And the next thing we'll move to is we will write just quick functions on these 3 types of data to see where could things be easier, where could things be harder, and like what data frame, what type of data makes sense for a certain task. Just to basically compare and contrast these 3 things. So now we will be processing this data from Julia. So let's see. So first of all, we're going to actually go back and work on this data set, which is just a very simple columns are year and then programming language. And we are going to ask 2 basic questions about this data. First of all, when is a given language invented? So if I have that data set and someone tells me when was Julia invented, I want to be able to write a function and find the answer pretty quickly. And the second question that could be asked about this data is when or how many languages were created in a certain year. Okay, so the first thing we will do is work with the matrix itself, which is an array of size or dimension 2. So very easily we'll pass the P, which is the matrix, and then the language is the language we're looking for. What we will do here is we will look at the second column, which is the column that has the language names. And here's one quick way to say, like, well, if we actually had so many columns, it would have been annoying to try and find which column it was. So if we were using a data frame, maybe here it could have been easier. But anyway, so we're looking here for the second column and looking for which language we're actually interested in as the query language. Once we found a location, we're actually going to go back to the matrix P and return P of that location, which is the row number of column 1. And now we can look for year created of programming language Julia, and that's going to be 2012. Now, if we actually run P of W, year created of W doesn't exist, and it's not going to like this. It's going to return an error. Just a quick explanation of what the error was or what went wrong here. Location or lock here, the variable wasn't able to find anything, right? So the number was nothing. And so P of nothing, 1, that's an error. You can only pass an integer as an index, so it complained here. So let's just do error handling really quickly. One way to do error handling is, again, we're going to find the location, but here we are only going to move on to the return statement if the location was not nothing. So if location was not nothing, it's going to continue executing this line. And by the time it reached this part, it's the return statement, so the function is over. So it's never going to make it to the error function or the error line. So if actually it is nothing, so this turned out to be false, there's really no reason to keep going on with that line. So what it's going to do next is going to go on to the next line, and the next line is immediately going to be an error. This is kind of like a more sophisticated way to write it. You can obviously write an if statement, but I just wanted to show you a different way. Maybe if you've used Julia before, that's a cool thing to know. And if you haven't, you can also learn this right away now. So, okay, so if we do our handling here, we are gonna actually get our error message that we wrote over here. Okay, so the next question we wanted to answer here is how many languages were created in a given year. So again, here what we will do is look at the column number 1 and look at how many, or look at all the times we found the year. So the length of this vector that we're going to find is actually going to be the number of years or the number of languages created in that year. So how many per year of P, 2011 is going to be 4. And we'll see that other functions are going to return the same value. Great, so these are the 2 ways we could use or process the matrix in this case. The next thing we will go into is data frames. So here we are going to call P of data frame is equal to C. So here we immediately have the data frame. C is, remember, the variable name we use to call the same data from the CSV package. So that's pretty easy to do it. I think I just wanted to show you quick things to do here. I think we've already covered this. So you could also do year of P column 1, language is equal to P of column 2, or just the data frame of P. You could also do, other things you could do is, since if you already have the matrix P and you want to create a data frame out of it, you could actually specify the type, since you already know that years are going to be integers and languages are going to be strings. So there's all these various ways you could create this P_df data frame, but we already have it here as C, so we'll just go ahead and use the data frame. Okay, so question 1 is again very similar to what we had before, except that here it's pretty easy to go ahead and think about like where was the language or where was the year. So we can just do PDF dot language, or we'll see later dot year. So really these two functions are super similar to what we had before, except that we didn't have to think, oh, was it column 1 or was it column 2? We can just access them pretty easily. Again, this is not going to work, and we'll do very similar pattern here, and it's going to be of Julia, 1012, and now if you do W, I think that's language not found. Great, so very similar, except that we can access columns very easily. Again, similar thing here, answering question number 2, except here we're not going to use the column name. We're not going to use the column index, we're just going to use the column name. And that's going to be the same answer. Perfect. Okay, so moving on to the last data structure, and that is dictionaries. So just because we didn't spend too much time talking about dictionaries earlier, we just saw them as when we loaded the JLG files or the mat files. Let's take a look at how we can create our first dictionary. Actually, what I'm going to do here, I'm going to remove this last tuple. So if I do this here, this is going to work. So this is going to be a dictionary where the keys are going to be strings and the values are going to be integer. So it right away knew that all the tuples we've passed are string, integer. So it was pretty smart in knowing what the type of that dictionary was. Now, if I go back to what I had before, you will see that this was an integer and now this is a vector. So will this work? Yes, it will, but the only difference is that now the keys are still strings, just because I'm passing J as a string here. And any is the new type, which identifies, unifies all the keys that as the values we're using, because any is, if you think of the types in Julia as a tree, you would have any at the very top, and like integer is somewhere in the branches, and vector is somewhere in the branches as well. But a vector is of type any, and an integer is of type any. So any is like the parent of everything. So this is the inference I just made here. So I think if I do actually a number here, it's going to go any, right? So yeah, any. Okay, so one quick way to declare a dictionary is by using just a dictionary, and it's going to default to any. But I think I already had here, yeah. So if you have an integer, vector, that's going to mean that, again, I'm declaring an empty dictionary with 0 entries, except that the keys are going to be integers and the values are going to be of type array, of string. So I can just decide on certain dictionary values. So P of dictionary number 67, just a random number I picked. It could be Julia programming. This is going to work fine. Now, this is going to actually give an error. This is going to complain. So yeah, this is not going to work because, let me just type a comment about it. This is not going to work. So P dictionary of Julia's equals 7. This is not going to like it just because we've already declared that the keys have to be of type integer and the values are going to have to be of type vector of string. So that's a quick intro or a quick idea of what dictionaries are going to look like. Now, what we will do next is, because we don't have our data in a dictionary or a data frame, we're actually going to create a dictionary of our data of the languages and their corresponding years. So this is one quick way to do it. What we will do is just go over every row in the matrix and see if year is already in keys of dictionary. If it is, we're just gonna append or update the value of that year. So dictionary of year is gonna be a new value that's gonna append that language to it. And if it doesn't exist, so that year hasn't been touched yet, we're gonna just create a new instance for it. Now, another way to do this, just because we know that this data is actually sorted by year, it could be just smarter to do it this way, and that is by just going by current year and next year. And what happens is that whenever we touch the next year, it has to be either equal to the previous year, so we just append the values of the previous year. We know it has to be equal to the previous year, or it has to be different, in which case we know its key doesn't exist already. So this is just a more sequential way of going through the data. Instead of looking for that specific next year in the entire set of keys, now we're only comparing it to the previous year, just because we know that things are sorted. So it either already exists or it has to be added. So both of these things will deliver the same dictionary. And if I actually go here, the length of P dictionary, of keys of P dictionary is going to be 46, and that's the number of 46 years, unique years. Actually, if we do here, length of unique of P of column 1, we're gonna see, column 1, sorry. I'm not sure what happened here. So P, so the unique values are so 46 entries. I'm not sure where did this come from. That's really odd. All right, this is why, I don't know, I feel like, oh, I see what happened. Oh God, wow. I already populated this thing. I shouldn't have done that. I'm just gonna declare it again. This is, all right, so let's do this again. All right. 45, perfect. Okay, so if we go back to the length here, so the length of the unique values in the first column is 45. Perfect, cool. Okay, so now we have the dictionaries and we have 45 unique years. The two questions we have to answer here are when was a given programming language created, and how many programming languages were created in a given year. So for the first question, so things may look a little more complicated here, but I do want to say that this line is almost identical to what we had in the data frame, and the matrix situation. So these are almost identical. And what I would want to say here is that instead of solving one problem in the data frame / matrix scenario on the entire vector of all the programming languages, all what we're doing here is that instead of solving that problem on the entire set of programming languages, we're solving essentially 45 different problems. For each year, as you see here, I actually collected the key values. For every key ID, I'm solving the same exact problem, given all these sets of key years that we're using. So that's really like, don't let this make it look super complicated. This is really just solving the same problem just 45 times. And the return value here, let me just explain this really quick. What's happening here is that, so we found a lookup solution for all of these 45 problems, right? What we care about is finding the lookup value that was nothing. So once we found the lookup value that's not nothing, that's the actual index that we're interested in returning. And that index will actually be the index of the year and the keys vector. So now we have only 45 vectors. For the 45 vectors, they have a solution. And when the solution is not nothing, so not nothing, that's the key that we're interested in returning. So I'm gonna run this and we're gonna see that we're gonna get the same value. One cool thing about using dictionaries here is that question number 2 becomes super easy to answer. All we have to do is really just find the length of P dictionary of a given year. Like that's all. We just have a key, which is the year number, and all we have to do is just get the length of its value. So it's pretty easy here, and that's about it for dictionaries. Yeah, so as you can see, certain things are easier, certain things are harder in certain data types. I would say if you have a matrix, or if you have data to play around with actually the numbers as a block of numbers, that's when you want to use a matrix. When you have a lot of data where you have columns and you want to be able to access the columns pretty easily and quickly, or you want to maybe join data frames, or maybe do a quick analysis like describe on them or something like that, that's when you want to use a data frame. Dictionaries are probably when you have a lot of, for instance, here we had like certain keys with like a lot of values, and you want to be able to solve certain sub-problems pretty quickly, or you want to be able to query a key really quickly and find out the answer right away. That's when you might want to use a dictionary. So really it depends on what kind of problem you have, but these are really the 3 common ways you could or you would want to store your data while you're working on a data science project. Now, before I end this notebook, really one last quick note about missing values. And I mentioned them here at the end just because like they sound like, oh, how do I deal with missing values? Like that's a complicated problem. But that's a really easy problem. Like you really don't need to worry too much about it. Let's actually introduce a new missing value in this data. And so as you will see, this first row, column 1 is going to have a missing value. So what I would want to say here is that throughout this tutorial, not just notebook, like the entire course basically, when we're looking with data frames, most likely we're looking at columns that are the feature names, and then we're looking at observations or instances as rows. So here, the row has a missing value. So when I set a drop missing on the data frame, very quickly I will see that one of the rows has been dropped. So if you have your data and you want to work with your data, work with your data without the missing values, you can very easily drop the missing values via the drop missing keyword. And so finally, I would hope that you can check all these boxes here by finishing this specific notebook. And if you have questions, obviously feel free to find me somewhere online and ask me questions.